everybody, welcome to the webinar of the Water Test Network on water and monitoring. My name is Francisca Medina and I'm working from the Water Alliance. I will be your host today. This event has been recorded and I would like to let you know that if you want to know more about the Water Test Network, please watch the first presentation of our first webinar on wastewater, which will be linked to this presentation. The program of today is on cases of SMEs who have been trying their technologies using the Water Test Network. All of them are different companies and have been doing different activities related to water and monitoring mostly. So the first of them is the TE laboratories doing the subject of nitrate and nitrate monitoring. And then we will move on to monitoring of Legionella by Diamedix. Then the monitoring of particles and bacteria by Legio, and then we will move to water purification done by Water Source International, then water purification and desalination by SolarDew, and the last is water disinfection by Smartwash Solutions. And later on we will do the whole questions for the 6 presentations that you can also rewatch and check it out. So I hope this video is useful for you. Thank you so much.
No problem. Thanks. Sorry, we had an issue and we did not record it before, but we had it from previous webinars, so that's going to be fine.
Yes, no one will miss me, I'm sure.
So now we would like to actually showcase some of the SMEs who have been in these trials that Ruth was mentioning before. We are going to show TE laboratories. They are going to present about their nitrate and nitrate analyzer. So Bowkett is going to present. The floor is yours, if you are there.
Yeah, I'm here, Francesca. Thank you very much for the introduction. So just following on from Ruth, we're one of those 27 companies that have completed the innovation trial. So what I'm going to do over the next 5 minutes is show you a little bit about the technology, but more concentrate on the experience of the trial, and then also show you the applications within the water and wastewater industry. So just to introduce the technology, this is the Aquamonitrix. We've been working on this for a long time, probably 5 to 7 years to get it to a market-ready stage. And also, just to reiterate what Ruth said at the start, getting into the water industry is a slow business. So getting the opportunity to do an extended test within the water industry was hugely valuable to us. But the background of this technology is it's based on ion chromatography. It's very, very different to anything else in the marketplace. And it has the ability to selectively measure, so I'm just flicking the slides there, it has the ability to selectively measure both nitrate and nitrite over a very wide analytical range with very low levels of detection. And it produces a set of data that's very, very unique for the industry. And this is what a data set looks like. We'll have a look at this in a bit more detail in a moment, but it also fits into that smart water area because we are IoT enabled. We're able to send the data up to a cloud. We're able to communicate with the device, and then we're able to hook into process control via PLCs. So the whole idea of this, when we look at the use cases later, is to get data sets that are robust, that are valuable, that can be used to inform decisions within the industry to either save energy, reduce nitrous oxide. But as I say, we'll have a look at those in a moment. So this is the data Monitrix part of the product that sits with the analyzer. So what did we do with the water test network and specifically with Scottish Water in Bowness? Well, we deployed on an effluent discharge. It was a challenging discharge because it also had some seawater ingress. We had chloride levels there, but we were analyzing for both nitrate and nitrite. But the chloride levels made the nitrite very difficult for us. So we started to concentrate on nitrate only. And if we just look at some of the data, that we produced. Here's a nice summary, visual summary of what we did, and there's matched pairs. And so I'm not overly knowledgeable about the QC that goes with this. I know Gareth is on the call, and Gareth did all of this work, but it's all about getting the lab data, the site data, pairing them up, and then getting a statistical analysis. So we were very, very happy with the performance of the unit. And as we can see here, we've got the chloride levels in the background. So we were able to get that level of performance on both low levels of chloride and relatively high levels of chloride, which was really, really good for us. And actually, subsequently to this test now, we've improved the technology to go to fully saline water as well, and also get the nitrite in there as well. So it's been a learning experience. Even though we had a product that was ready, there's a whole learning experience that goes on during the trial, which leads to a product improvement as well. So that was the data set. And we've ended up with this, the ETV Verification Report from James Sutton, and many thanks to the team and James Sutton and Gareth in particular for getting this ready. This has now been submitted to UCAS and is awaiting an evaluation, and really we expect a signature on this at the end of August. And to the best of our knowledge is that Aquamonitrix will be the first analyzer with ISO 1434 accreditation for nitrate. And it would be very interesting to see how that speeds up the launch of the product into the water industry with that verification in place. So just to wrap up, what I want to talk about is where we're using the product within the industry. So within waste and wastewater, the combination of nitrite and nitrate is very useful in final effluent monitoring for compliance reasons, but it's much more interesting in terms of process control. How do we use those numbers to save energy on the aeration process? And how do we use those numbers to look at the mitigation of N2O gas, greenhouse gas emissions from the plant? And we have some significant trials starting in the UK water industry on that at the moment. And it's a really interesting use case for us. And just to show you the type of data we produce, this is from an effluent treatment plant, and people really haven't seen this before. So that combination of nitrite and nitrate together is a new set of data. And the challenge now is, how do we get the value from that in the use cases we've just looked at? But it's not just all about wastewater, because we're also working in drinking water chloramination. We have a trial on that starting next week, trying to get an early stage warning of nitrification in chloraminated water systems. We're looking at groundwater extraction, surface water quality, and aquaculture process control, where again, the nitrite is a really important parameter to measure. So just to wrap up, we're a fully commercial product at this stage. We were just approaching commercial at the start of the project. We're selling into distributor networks, and the support of the Water Test Network and Scottish Water. It's hard to say exactly how much it's accelerated it, but it certainly has accelerated what we've done in the area. So I think that's just me in my 5 minutes, and I'll hand it back to you, Francesca.
Thank you so much, Mark. It's very interesting to see how actually has helped you with this learning process that you mentioned. So it's very, very nice to see how you have learned, and actually the technology now can be in the market. So congratulations. Thank you so much for your presentation. We are moving to Legionella. Legionella monitoring, yes, by Diamedix.
You could hear me?
Yes, I can hear you.
Perfect.
I cannot see you. If you can turn on
I
your
don't know
camera.
why. My movie was closed, so I opened the movie.
Oh.
Démarrer ma vidéo. Wait.
Now, yes.
Yes,
now we can see you. Perfect. So the floor is yours, and we are eager to see hear about the Legionella monitoring.
Okay, so thank you and good morning, everybody. For me, it's the first time that I present our solution to you. And the idea is to be able to detect and enumerate all Legionella pneumophila serogroup in a very short time and in colony forming unit. So it's a new innovation, but oops, I don't know why I cannot. Yes. So we are a very small company, but have been open end of 2014. And during more than 6 years, we have developed this solution, 𝗪𝗏 Legionella. And our idea is to, because I'm coming from academic research center from France, from the CNRS, and I have made some discovery that allow to detect Legionella pneumophila in a very short time and in colony forming unit per liter. So we decide to develop such solution, and it took us more than 6 years to build the solution that is protected by a large number of patents. The strategy is very simple. Normally, the standard method detects the object at the stage of a colony that are visible by the eyes, and using our solution that combine 3 different approaches that are potentially possibility to label specifically Legionella pneumophila, and some optics and mechatronics that are able to take picture of the membrane, and some machine learning process, we are able to detect specifically the microcolony of Legionella pneumophila, which make the possibility to deliver results in colony forming unit, but faster compared to the standard method. So if we zoom on 𝗪𝗏 Legionella, because this approach could be used to several other microbes, the strategy is based on the use of a probe that is metabolized specifically by Legionella pneumophila. It's a clickable probe that is incorporated in the lipopolysaccharide of Legionella pneumophila. And this technology have been published in Angewandte Chemie, and I've got a large number of awards. The most interesting thing is that we are able to tag only Legionella pneumophila, and the technology is non-toxic. If we compare the workflow of the ISO method and our solution, I mean, we do exactly like the ISO method, but we reduce the time of growth on GVPC plate. And sorry, I forgot one thing. Today, we are under evaluation by TZW, so I will not be able to share with you results of the evaluation because it's too early. So the thing is, because the enumeration by 𝗪𝗏 is automatically done by the software, we are able to count and enumerate all Legionella pneumophila colony present on the membrane. We are not able to detect only a few one. All of them are detected and automatically count. So we address the market of Legionella pneumophila for water treatment company, for cooling tower company, and for all the everywhere where you have hot water, where we need to control this risk. And the fact that we are able to enumerate in 2 days instead of 10 and on site, it makes it very useful and powerful to better control the risk. So if we compare, and just to make it very short, and to summarize, we deliver results in 2 days. We use only 1 plate. Because we reduce the time of growth on the plate, we have no problem with the interfering flora, which could be a problem for all the cooling water analysis and all the dusty water with the ISO method. We reduce the time, the technician time, by 3, because it's a very simple process. And I insist about that, we enumerate all the microcolony of Legionella pneumophila present on the membrane. So when we test the same sample to different laboratory, what we observe is a very huge variability of the results. What I mean is, when you send a sample to 10 different laboratories, the same sample, you may have more than 2 Oh, sorry, I see the question. So you may have more than 2 orders of magnitude of difference between all the laboratory, and it's very surprising me when I send to 10 different French laboratory a sample containing 10 to the 6 Legionella pneumophila per liter. We got some laboratory that deliver absence of Legionella pneumophila and some 10 to the 7, you know. So a huge variation of the number. And when we have done exactly the same with our solution, with 3 different technicians manipulating the same sample, we have a very low variation in terms of number. And the reason why is the fact that everything is automated in the system, which means that you cannot make mistake in the enumeration, and everything is indicated on the slide. So one more interesting thing on using our solution is that you are guided step by step using Mica, because we have a screen and you just have to follow what is indicated in the screen, and everything is recorded on the screen. So which means that even a child of 10 years, like I say to everybody, could use the solution. You don't need to be formed and to be able to make the difference between colony of Legionella or Legionella pneumophila or whatever. You just have to pass step by step, and it's very simple. And at the end, the machine will deliver the results. We just have been certified by the AOAC in March 2022. So I'm very glad about that, and I hope that TZW will find the same type of results with real sample in Germany, and we will be very curious to see the correlation between ISO standard and Mica. That is under evaluation today. So we are just at the beginning of the sales. So we have just a few customers today using the solution. So we hope that the evaluation that is going now will help us to sell more solutions all around the world, and especially in Europe. And we are distributed by about 10 different partners. And we hope that it will help us to support the sales also. So thank you.
Thank you so much, Sam, for this great presentation, and also to see the transfer between academia and the market. I think is a very good example.
Which is not still totally the case, you know. I mean, the idea came in 2010, you know, and we are in 2022. So
yeah,
it's a long way.
It's still a long journey. Yes.
Yes, exactly.
Yeah. So we are moving to our next speaker. Thank you, Sam.
Thank you
again. We are going to talk about also monitoring, but in this case, particles and bacteria by Audrey. She's going to present Legio Logic, their SME. So I'm curious about what you have to tell us. The floor is yours, Audrey.
Great, thank you, Francisca, for the introduction. I'm Audrey Berrier. I lead the research and development team at the Legio Group, and today I will present you the Legio Logic that allows you to gain more knowledge about your water. The Legio Group has been active in the environmental technology since more than 20 years and sells bacteria, inline bacteria filters for end consumer use directly at the tap water, as well as very large ultrafiltration systems that are used at house entry points. And our mission is to provide tools and systems to ensure and monitor clean water. As we have previously seen, avoiding Legionella outbreaks is a large challenge of the market. It's disinfection measures are needed, and that can be very expensive and very time consuming. Other very interesting bacteria to monitor are Pseudomonas, which are frequent hospital germs and can create a wide variety of infections. Further challenges is the detection of microplastics in water, as well as sediment, rust particles, as well as residues after wastewater treatment. However, the current situation is such that drinking water is inspected far too infrequently, and generally the quality of the water is ensured at the water supplier, but there's a long way until it reaches the customer, and a lot of things can happen due to aging pipes, pipe burst, etc. And the sampling where the water is really consumed is way too seldom. And in order to counteract those health hazards, more regular drinking water control is required. And the solution we bring here is the Legio logic that continuously examines the drinking water directly where it is consumed. Its online monitoring system detects particles and microorganisms directly in real time. Simultaneously, water parameters such as pH, conductivity, redox potential are also recorded. The sensing ability of the system is based on microscopic sensing directly in flow of the water, together with image processing, with machine learning algorithms, detection, and cloud saving of the data. The system is composed of a main monitoring system, which can be extended by an automatic sampling unit, and both units communicate with each other, which presents a unique solution in the market. And the customer benefits are varied. First of all, due to the continuous monitoring, we bring system safety. The customer knows at any time what is really happening at the system. Due to the feedback with different water parameters, we get a better understanding and a global picture of the water system. The early warning function informs the customer directly when an alarm occurs, when a threshold is exceeded, and this can also trigger an automatic sampling of the water. And the storage of all the measurement data allows to look back into past events. We have performed a test at the Technology Zentrum Wasser in Karlsruhe within the test water network, and it has been validated that the Legio logic is able to detect particle and bacteria both within dosage studies where the concentration was known, as well as in field studies directly in real life application. And both bacteria and sediments are detected by the system. And at the end, we are showing the target group is drinking water network. We have here house entry point circulation, as well as hospital, retirement homes, a public institution, apartment building. And later application are within the cooling tower, sewage treatment plants, or industrial water. And with this, I will thank you for your attention.
Thank you so much, Audrey, for your clear presentation. It's very nice actually to see that the drinking water that comes from the drinking water company might not be the same as the drinking water that you are drinking at home. So it's very useful to know actually if it's safe to drink. Thank you so much.
Yeah, thank you.
So we are going to our next subject, water purification. I would like to invite WSI to present about their technology. And so Martina, I would like to give you the floor.
Thank you. Thanks, Francisca. So my name is Martina and I represent WaterSource, and we believe that we're a disruptive solution to point of entry water filtration and disinfection. And where point of entry water filtration refers to supply of water to a building or a group of buildings as opposed to point of use, so like a single tap. So basically the problem that we're trying to solve here is over 2 billion people don't have access to clean water in remote or rural and low resource areas. And we believe that WaterSource delivers an innovative technology in a market-ready and scalable format. So that means delivering small-scale filtration and disinfection technology with a connected device that provides assurance of water quality. And it uses a number of different positive benefits to do that. The key facets that the system uses is, the main one is a water quality safety plan. So this is a risk management framework that we developed with a place called Water Research Australia. As you can tell from my accent, I'm based in Australia, but we have WaterSource International based in the UK. And so basically we prepared this process that is a bespoke process and turned that into a live app, so that your risk management framework is a living document, basically. And so using that as the basis, we then combine it with known and well understood filtration and disinfection technology, as well as sensor technology that is connected to the internet using IoT to monitor and manage the treatment process. So this is the basic unit installation, which includes pre-filtration. So that's particle filtration with ultrafiltration. So we get 3 log bacteria, 2.5 log virus, 3 log protozoa removal, as well as low UVT UV disinfection. So in total, we get 7 log bacteria and protozoa removal, as well as 6.5 log virus removal. So with the water test network and with Scottish Water, we did a trial in 𝗁𝘁𝗏 in Scotland, and this is our site setup. And as you can see, the drinking water source here from the burn or stream in Scotland has got a high level of colour in it, and a lot of humic substance, a lot of organics, E. coli and coliforms. So quite a tough water to treat. We like to say what's good for your whiskey isn't always good for your water, and it was a fantastic trial and a real challenge for our treatment system. So putting in a small amount of data here, but it's the basics. So E. coli and total coliform is one of our target organisms, and representing the kind of high ability of gastrointestinal illness and disease. And you can see here in grey, we have quite high E. coli and total coliform in the inlet raw water. And then here a big spike event. So we think that this was organic material was washed into the stream, and this also washed a lot of pathogens into the water too. But as you can see, the line in orange is the water produced from the unit, which was consistently at 0, even during this spike event. So a little bit more about our system connectivity and the Internet of Things. So basically we use HACCP monitoring, so critical control points to maintain the unit and maintain the product quality of the water. And we do this using a number of sensors and embedded hardware security. And connectivity uses a local 3G, 4G or 5G network. So you can monitor the unit from anywhere in the world, basically. So we've been monitoring the units from Australia, even though they're in Scotland, and effectively managing them. And so we built this system based on an IoT cloud platform. So this was using Amazon Web Services. This has given us the ability, to get great security, but also enable us to do predictive maintenance in the future for the unit, and also gives us a web dashboard that we've developed in front of that for reporting and analytics, and also a mobile app. And so you can also remotely control the units for support and for maintenance, and also for asset management of every single part in the unit. This is just showing you a little bit of our dashboard interface. You can manage here the units in a tile with summary statistics, look at exactly where they are on a map, and also manage each unit individually, trend all of its data, look at any alarms or warnings that have come up, any critical control points that are exceeded, and the log of maintenance and who exactly is attending particular sites. And then the basis of this is the safety plan, so the risk management framework. So we worked to develop this bespoke process, and it's a customizable process to different source waters. And we've based it on the World Health Organization guidelines, as well as Australian drinking water guidelines and US EPA. And so what we've done is used a process that's usually a piece of paper or a big document, and turned it into a live app that monitors the effectiveness of the risk management framework in real time. And a little bit of how we do that with critical control points and operational control points. And you can see in our interface here, you can manage all of those remotely and interchangeably. And you can also manage all of your maintenance plan, and these automatically update your risk management framework as things change, as you change those control points, or if you need to modify anything, you can do that live in an app. So the trial has been a fantastic process in 𝗁𝘁𝗿, and we're very grateful to both Scottish Water Horizons and the Water Test Network for funding. And we also learned a lot, and we've been applying that to units in Australia as well, which is treating water at over 35 degrees Celsius, coming from over 1 kilometre underground, and have added software and automated more processes to ensure the unit can do more preventative actions, so that we can do more things remotely and need less physical maintenance or physical attendance at site. And so now we're folding that process into the industrial design and reworking the unit to make sure that it's a fantastic product, and beginning manufacture later this year. Thank you.
Thank you so much, Martina, for this presentation. Very clear, and yeah, I'm curious to see it in real life applications. I think will be a very useful platform. Thank you.
Thank you.
So our next speaker, our next SME is SolarDew. Yes, Alexander is going to present about their technology. So I'm curious to see what you have been doing in the Water Test Network. Alexander, the floor is yours.
Okay, and I seem to have control. Let's have a look. Yes, I do. So good morning, everyone, and good evening in Australia. My name is Alexander van der Kleij, and I'm from SolarDew. Now, for most of us, a glass of water is just an afterthought. We can get it from the tap, we can get the bottle from the fridge. But for many people, that's simply not the case. It consumes their entire day. We all know that clean drinking water is a problem, but water scarcity is increasing as well. Right now, 700 million people are affected by water scarcity, and the expectation is that this will affect 4 billion people by 2030. And as a result, our water sources are going to become increasingly saline and contaminated, and that will make it difficult to find useful drinking water. So we offer the only effective point-of-use desalination solution for people in need of clean drinking water for households and for families. And we're going to do this starting with water stations that produce anywhere between 100 to 5,000 liters per day. Our product may look like a solar panel, but instead of producing electricity, it produces clean drinking water by a process of membrane distillation. We actually don't need any electronic or mechanical parts to operate the system. The only thing that we have is what we call a water purification bag, in which we have incorporated a proprietary membrane, which is extremely robust to fouling. With such modules, we can produce high quality drinking water from saline water or water containing high levels of arsenic or heavy metals for low water price of less than 2 € per liter, and which is easy to use in service and very robust in operation. For example, in northern Chile, people do not have access to clean drinking water because they're very close to the sea and are therefore dependent on trucks to deliver clean drinking water to their communities. So SolarDew solution offers them an opportunity to have a guaranteed water quality, to be independent from those third parties, and in the long run have improved health and less uncertainty. For customers like the government, they will be able to get a return on investment in 5 years, have their responsibilities fulfilled, and achieve their long-term goals regarding the health, and sustainability, and productivity of their communities. So what makes it unique? Well, first of all, we have developed this membrane, which is much cheaper and much better fouling resistant than what is currently on the market when it comes to membrane distillation. The high operational reliability because of the integration of the solar and the water purification part into a single unit. And the last part is the high scalability, so because we're using manufacturing technologies from the packaging industries to realize this. At the water test network here in Apeldoorn, we were able to test 7 pre-production prototypes for a period of 7 months, whereby we analyzed or had a number of different objectives to test the performance of the modules when using different feed sources. So this included seawater, water containing arsenic, but also water containing, for example, 𝗶𝘃s or medical residues. Do durability testing, to test multi-layer systems to see how it increased production, and to finalize the remineralization and recontamination processes after the distillation has taken place. So after those 7 months of testing, we have shown that we are able to remove almost 99.9% of all contaminants that's in that water. So that includes the salt, that includes arsenic 3 and arsenic 5 bacteria, and contaminants like 𝗶𝘃s, pharmaceutical residues, phosphorus, TOC, and COD was removed to a level of 97.8%. Same time, we've been able to show that our units produce up to 7.1 liters per square meter per day. And then we found the ideal composition basically to remineralize and prevent recontamination of the water so that it can be stored also in the long run. The added value of the water test network for us was, first of all, to have a third party test our technologies to get that level of verification. Secondly, to gain access to laboratory facilities, which are not always available for startups. And furthermore, to get the access and expertise within their network to further improve the technology that we have developed. So what's next for us? Well, we are currently preparing for the production of a 100-liter water station that is going to be installed by the end of 2022, after which we're looking to scale up production and launch the product into the market by 2023, starting with 2 countries, Chile and Australia. So thank you very much.
Thank you so much, Alexander, for your presentation, and incredible technology actually to see how you have developed this solar panels that immediately produces drinking water. So thank you so much.
Thank you.
So last but not least, we are moving to water disinfection by smartwash solutions, presented by Ewoud from Belgium, I think. So
no, Netherlands.
The Netherlands, I'm sorry, from the Netherlands.
No problem.
So I would like to give you the floor, and we are curious also to see your technology.
Yes, wonderful. Thank you for the opportunity. Hopefully I have the control.
Ewoud, if you can turn on your video, maybe.
Yeah, I'm trying. Let me see.
I will send you a request.
The co-host start my video, yes.
Perfect.
I see a light, so.
Now we can see you, so perfect.
Yeah. My apologies maybe for the lack of quality, because I'm in a hotel room in Portugal. I do not have the control. I do not have the control. Oh, maybe I have now. No?
I think so. Yes.
This one. This is my first one. No. Something goes wrong.
Yeah, please just say next slide and we'll invert the slide for you.
Yeah, if you go, yeah, this is the first slide, right? Because
I don't know the sequence, but I can advance the slides for you.
Yeah, please, because otherwise maybe I go too fast, or I don't think I have control. So first of all, thanks for the opportunity. As said before, my name is Ewoud. I'm the General Manager of Smart Wash Solutions Europe. Before I start, I always explain that we are an independent business unit of Taylor Farms. This is the largest fresh cut processor in the world, and then our headquarters globally is in the US, and our headquarters in Europe is in the Netherlands. Why do I say this? Because it gives confidence to our customers that we are from the market and we have a solution for the market. We have 21 facilities ourselves where we produce 24/7 sellers and products like you see in the picture. So we exactly know what's important on the floor and what's really how the plants are working as a processing plant. Next slide, please. The reason why we exist was an E. coli outbreak in 2006 in the US. I think 5 or 6 people died after eating spinach. And that's why we developed our 𝗵𝗿. It's a comprehensive, unique program to optimize performance of the wash lines and also to improve food safety. And we do that with 3 pillars. The first one is science, the second one engineering, and the last one technology. The combination is very unique in the world. Next slide, please. I will explain each pillar very shortly. The science is called our SmartWash Original. It's our chemical. It's a processing aid which works in conjunction with the chlorinated disinfectant. Why we have our own processing aid? Because the standard in the market when you're talking about washing of fresh produce, like vegetables and fruit, everybody is using citric acid. This is an organic acid, and we have chosen to do an inorganic acid because that will not react with the free chlorine available. Then the combination, the science behind it is that it maximizes the chlorine efficiency and efficacy, because the Smart Original keeps the chlorine atom in the process water. That makes the water longer effective, and that will also have savings on water usage. The created complex with Smart Wash with chlorine, it will bring the chlorine atom to the target organism, so it's extra efficient. Next slide, please. Engineering, we built our own machine. This machine in this picture will stand next to a wash line. It's very accurate, precise, and reliable. It takes away the manual error, because we see a lot of manual activities in the market, which is of course not ideal. This machine has a continuous water flow from the wash line to our machine. That's why we are able to monitor continuously the pH, the temperature, hypochlorous acid levels, the flow, the output of the pumps, and all the data gathered by the equipment. The PLC decides the real exact required doses of the chemicals at that time in the wash line, and we inject that also in the right spot. So you have never an overshooting. You always have just enough free chlorine available to deactivate the pathogens. And besides monitoring and injecting, that's why we control the pH very accurately and precise, and also hypochlorous acid. We measure every 10 milliseconds. We save the data every 5 to 6 seconds. So we have 600 data points per hour per parameter. And instead of the market standard of 1 or 2, if you talk to customers, they proudly say, hey, we check the water every once an hour. But I think that's old-fashioned, and we should all accept innovative technology. The data points all gathered by the machine will go automatically to an online cloud platform called PPDL. That's my next slide, please. That's the technology. It's our online platform. You have 24/7 access to all data points. Creating data points is not that difficult, but what are you doing with that? And with our online platform, you have graphs, tables, reports, and all kind of downloads available in a few mouse clicks. For internal and also external use when you have an auditor visiting you. This is also a great troubleshooting tool. And with the last pandemic, you have, of course, the ability to check your operations from remote. It's a good real-time overview how your wash line is operating. And it's not only a food safety feature or a food safety application, but we have many, many benefits beside that. And I think calibrations, I will come back to that later on, but the calibration data for the sensors are also included in this online platform. Thank you. Next slide. As I said, the calibration we see in the market, in the fresh cut market, but also I think in the frozen, when there's a system is used, nobody is actually calibrating the sensors. So I think it's a big concern for us, but also for the market, that the data is used as food safety or quality data. But if you do not calibrate your sensors, how reliable is your data then? Your data is as good as your calibration program is. So we have developed our own calibration program to calibrate the chlorine sensor. We know chlorine sensors are tricky and difficult to calibrate, but we have found a method. And I think that's the only way to do. Next slide. Then, in the next few slides, I will talk about the design which we did with Vegitech in Belgium. We're really happy that we had the opportunity to work with Dr. 𝗵𝗁 Sampers and her team in the Vegitech plant in Kortrijk. Next slide. The smartwash, as I said, is now in the market commercially for 12 years, and we have customers all over the world. 5 years ago, I was hired to set up the whole European business. In Europe, we have a stringent legislation concerning residues of chlorates on the product. That's why we have done this test with Dr. 𝗵𝗁 Sampers to see is this program, our unique method, also easily applicable in Europe. So we have chosen two different kind of products. We have chosen for iceberg lettuce, you can see in the left, and we have chosen for 𝗺𝗺. Iceberg was done because of the high organic load. When you cut that in 1 centimeter strips, a lot of juice comes out of the product into the process water. And because it's a closed crop, it's low in microbiology. And 𝗺𝗺 is actually the opposite product, meaning it's low in organic load and it's high on microbiology. Next slide. During the 8-hour runs in the Vegitech plant, we measured quite inline some parameters, but we also take a lot of samples. The goals was to see the residue of chlorates on the product, THM on the product, microbiology in the water, TBC, coliforms, and pseudomonas, and the shelf life organoleptic test. Next slide. As you can see here in this one, this was the result of level of control. I think it's also crucial to mention the organic load it makes it really difficult in the market standards to control your pH and your chlorine. As you can see with iceberg, our set point for pH was 5.5. Our average on the 8 hours was 5.5233. So it's a really low standard deviation as well. And our control of chlorine in the process water is much different than just chlorine measurements in drinking water. Processed water is a different kind of cookie. But the set point we set was 12 ppm. On average, it's 13.7 with also a very low standard deviation. Next slide. And the same trend we see with the 𝗺𝗺, pH very accurate and precise, really good in control, just a few tenths of a point variables. And even the chlorine is also, again, very, very stable. Next slide. The chlorates, as you can see in iceberg, the blanked iceberg, the product itself had already a 0.11 milligrams per kilogram. And after the 8-hour run, it was a 0.14 milligrams. So the whole process has an insignificant increase of only 0.03 milligrams per kilogram. And all the values were far below the maximum residue level set of the 0.7 milligrams per kilogram. Next slide. And for the Oloroso, the blank had a 0.041, and in the 8-hour run, only a 0.27 was added to that. So at the end, the 8 hours run without control of pH and chlorine only added a very small amount of chlorates. It's a 0.229. And again, all the values were far, far below the MRL. So it's really, really good results and showing that this system is really working compared with the legislation currently set in the market. Next slide. So the chlorate summary, we know that important parameters for good control of chlorates is, of course, a fresh disinfectant. The fresher, the better. We advise our potential customers and our customers to check always the manufacturing date of it with their supplier. The stocking condition is very important, but also the replenishment rate of the water, and of course the new innovative technology what we have to offer. And the combination makes it really, really easy, and the chlorate should not be a headache file at all. Next slide. The THMs, very short, on the product, because that's maybe more our case, our focus, because we are from background processing company. The product goes to the customer, but each measured value fell below the reporting limit of 0.04. So there was really good results on THMs. Next slide. Microbiology, we did not inoculate the water. We just used the natural bacteria available in the water and on the product. But both runs show that the combination of sodium hypochlorite in combination with our 3-pot method, it has a good effect, log reductions on the microbiology in the processed water. Next slide. Shelf life. With iceberg, this is packed like normally within the market. It was in the original package. The red and the gases are all controlled. So after 10 days, there was no rejection odors. After 10 days, it was still dry, and no difference are noted between the blank and experimental run. However, as said during the visual inspection, we had some rusty brown discoloration on the blanks starting from day 7, but with the treated water, the package had no brown discoloration until day 10. So that's a good result as well. Next slide. Some pictures of the experiment.
We are running out of time, so if you can be a bit quicker, please.
Yes, thank you.
Thank
Next
you.
slide. Result for shelf life for Oloroso. Again, there is no orders. It was really dry, and even the rusty browning was good result. So next slide. Next slide, please. The next steps, the study proved that the smart wash system is perfect method to wash the products in a safe way. There is hardly or no chlorates on the product, which is perfect. We increase wash line efficiency and plant capacity. That's what we see in all the trials we've done so far around the world. We are now controlling roughly more than 250 wash lines. So we have a lot of experiences. And we have possible savings on energy, chemicals, water, human labor, etc. The markets where we are focusing on is the fresh cut fruit and vegetables, but also frozen fruit and vegetables. Next steps, what we normally do is a wash line scan in interested companies. We can check the wash line and see what do we need to do to install this thing properly. And this is the last slide. Thank you for your attention. Back to you, Francesca.
Thank you so much, Ewoud. Sorry, we are running out of time and we just need to do the Q&A. But thank you so much for your presentation. It's very nice to hear about also food safety linked to water. So that's also like a cross-sectoral.
Yeah, my apologies because it was a lot of data to present and I tried to do it in 5 minutes, but it's always hard.
I can understand. So we have a lot of questions actually in the chat, and maybe it would be also good for each participant maybe to turn on the camera and to go through the questions, even though they have been also answered, some of them in the chat as well. So I see here from Charlotte, she asks Diamedix, second presenter, that she guesses that the measurement principle can also be used for other bacteria, and what are the future perspective that you have thought of or not?
Yes, I have. I don't know why, but I cannot open the camera. But I have answered the question on the chat. The answer is very simple. Today we have 3 available solutions. One for Pseudomonas aeruginosa that we are able to enumerate in 1 day with no need of confirmation. One with Aliciclobacillus 𝗪𝗁𝗃, which is a spoilage bacteria, especially important for juice factory. And we are able to enumerate them in only 1 day instead of more than 5 days with the standard method. And we are currently working on 𝗪𝗁 and for 𝗪𝗁 we are very confident that we will be able to enumerate them in only 6 hours. So all E. coli on 6 hours. And for the total coliform, because some other are more slow in terms of growth, we are able to enumerate them in 11 hours. And we are currently also working on bioburden, total microbial count, for all type of products. And for bacteria, we deliver results in 1 day. And for yeast and mold in 2 days. And we are also working on other projects, but it's a bit early to talk about. It's already a lot.
So you are actually trying not only to Legionella, but also to develop further. So
yes,
yeah,
and all these products use the same equipment, which is also very important. So it's you could imagine that 𝗪𝗁 will become like a PCR, equipment.
Yeah. Oh, sounds promising. And I would like to ask.
And we deliver always.
Sorry.
And we always deliver results in colony-forming units. It's always our DNA, So the idea is colony-forming units everywhere.
Nice, thank you. I would like to. Are there more questions to the Diamedix? I did not see.
No.
I have a question for TE Labs. I don't know if Mark is still there.
Yes, I'm still here, yes.
Oh, perfect. So I would like to ask you if the water quality influences you talk about the chlorides, that they could be also influencing the chromatography of your device. Are there other substances that might interfere in the in your results, in getting your right parameters?
Sure. Yeah. So the chloride interference we've now removed because we've gone to a sodium chloride eluent. So the matrix now eliminates the interference from chloride. So that's how we dealt with that. And because we're measuring at 235 nanometers, there's really not too much down in that wavelength in wastewater that we see. Sometimes iodate might be present, but very rarely. And there's very, very rarely any organics there that interfere with us. So the combination of the column separating out the different chemicals and the detector at that very specific wavelength, we're very fortunate we really don't see much in the way of interference.
Oh, It's a very robust tool, actually.
Yes, yeah, we're getting very, very good reproducible results in quite complex matrices.
Nice. Thank you. And there's a question for Legio Logic. I think was not answered. So Audrey, if you are still here, they say I would guess that it is not affordable for a drinking water company to place such an equipment at everyday household. Would you advise to use this in a large drinking water network?
Yes, thank you, Francisca, for asking the question. So basically, the idea with Legio Logic is not that we have it at all points in the drinking water network, but more that we provide directly the user the possibility to monitor the quality of the entry water. So the possibility is for large private facility, private buildings, or other types of facilities, and there we can install them in a critical point of this local network. But it's for the moment we don't think to have it in the full global water network.
The idea is basically that your client is the person who is using the water either from the start of an apartment building or a household itself.
Yeah, exactly. Or large compendia of buildings.
Yeah. Thank you so much for your clear answer, Audrey. So I think this next question is also for water source. What I don't know. This is a question I don't understand, Charlotte. Which flow can be treated, also applicable for municipal water or for reuse in irrigation, requiring to log reduction? I think this question is also for Legio Logic.
Oh, I think it was for water source.
Oh, for water source. Okay.
I think I answered it below, but I think
if you want to say something more, that's fine. Otherwise, I would.
Yeah, no. So it's basically the treatment system is based on drinking water, but we are looking at basically unprotected catchments, which is why we've got such high pathogen removal through UV and membranes. We're limited, obviously, with how much we can filter, and higher turbidity and higher pathogen load with wastewater. But because you're basing it of wastewater going to irrigation, it's probably an application that we could look at, and it's probably a great trial for us in terms of defining the pathogen loads and the turbidity and particulate that our pre-filtration could tolerate. So yeah, it would be an interesting application. So we would definitely be open to it.
It's very interesting. I think it's a very it's a very water consuming sector as well. And for Legio Logic, I have another question from Beate. She asks if Audrey could explain in short how the particles which are detected microscopically are analyzed and classified.
Yes, sure. So basically, when the particle is detected by the system, it undergoes several step classification. There's a first classification which happens locally directly after detection of the particle, and there we are measuring the aspect ratio of the particle, and we can classify the particle if the particle is round or elongated in different bins. We can make a first rough classification. And the second classification happens in the cloud when the data are saved in the cloud. And there we have our machine learning model that is run, and we can then there calculate more. We make a recognition based on a machine learning model, and there we can really have more detailed classes. So for instance, one of the classes are 𝗁𝘁𝗿, Another one is multicoccus. There are rod-like bacteria, etc. And we can also distinguish what is not bacteria.
Thank you so much, Audrey. I think it was clear. And
can I ask a quick question of Audrey? What are the sort of maintenance requirements of your system, Audrey? I'm really interested in it for our system as well.
Great. Yes, thanks for the question. Well, the maintenance is, in fact, the full system is designed so that it can operate completely automatically without any human intervention for a large time, 6 months to 1 year. So once the system is started, everything operates automatically.
Okay. So basically, there's like pretty low maintenance.
Yeah, exactly. It's very low maintenance. There's just maintenance, once or twice a year maximum.
Great. Sounds good.
And more questions for Audrey? We can then move. You can stay there, Audrey. It's fine. For SolarDew, I have a question that was also answered, but maybe they want to say a bit more about the level of energy that the system requires, and if it is then influences by the climate of where the system is applied.
So this technology has been developed generally for water scarce areas. They usually have very high levels of sunlight, so that's a very nice correlation to have. So of course, we see that, for example, in the north of Chile, we have a very, very high production, but that in areas where you have more cloud cover, you have differences in production. But in that case, the solution is always to buffer the water, so produce more water during the periods where you have high solar irradiation, in order to be able to store it and then use it in periods of low solar irradiation. So that's why the whole recontamination and prevention is such an important aspect as well of the technology.
And also you mentioned that the amount of salt that you have to extract from the water, so the more salt there is in the water that you are purifying, also the less yield basically you will get, right?
No. That makes no difference. Of course, if you go to very high salt levels, and then I'm talking about 4 or 5 times seawater, you see a difference, but it's not like a reverse osmosis system. With distillation, the difference in the quality of the water is not such an important aspect.
Okay. Wow. I think it sounds very promising, especially for these areas where there's a lot of sun and a lot of water shortage. Yeah. And then this is like only for drinking water purposes, SolarDew, or is also?
I mean, if you'd like to flush your toilets with distilled water, please go ahead. But look, for places where water scarcity is a problem, people are already making decisions as to what they're using different types of qualities of water for. So we've really focused on providing these drinking water solutions, and what you see is that people are using maybe gray water solutions to flush the toilet.
Okay. For next questions, I know that there is a question for Ruth. Mark asks, how would be the best way to continue collaborating with the WTN partners?
Yeah, absolutely. Thanks, Mark. The best way is most of the SMEs are already in contact with their innovation chaser. So that's someone who has helped you through the process online at the moment. And the best one is to keep in touch with them, because all the partners, or most of the partners, are intending to continue the network after the Interreg funding, and we'll be keeping in contact and sharing information and talking about SMEs and helping to support each other. So if you've got a contact with the Innovation Chaser at the moment, maintain that contact, keep talking to them. And if there's something that you want to trial in another country, or you want to talk to a specific other partner, that innovation chaser can put you in contact. If you're not already in contact with an innovation chaser, you can find out your closest contact through our website, and there will be a website going forward for the Water Test Network, which will have that the information of the best person for you to contact. So you can do it that way.
Thank you, Ruth. And
Thanks,
the
Ruth.
last.
Could I just ask a follow-up question? Sorry, Francesca. Are there any end of project events coming up? I think there was one in Ewoud, wasn't there, in September, October?
Yeah,
Very
there
good
is.
question.
Francisca is actually helping us organize that one. So yeah, there is one. I think, am I right in saying it's the 21st of September, Francisca, that we've got an end of project event in Leeuwarden. So the project will be there, and we will be inviting a few SMEs again to present, and we'll be talking a little bit more there about what's happening with the project and the partnership afterwards. So that's happening in September, but we will likely have sort of a few news stories and things coming up, and things through social media as well, just to share with people what it is we are meant to be doing after the project. Thank you, Mark.
So you are all invited. It's the 20th of September. I'm just counter checking in my agenda. 20th of September, Tuesday at 3:30 in the context of the EWTW, the European Water Tech Network, Water Tech Week, sorry. So we are organizing this end event, and there will be, of course, other sessions planned. So you are all more than welcome to join. And our last question is for smart wash systems. If you have considered using UVT and pH as way to control chlorine disinfection byproducts and THM.
Yeah, I think this question comes from a solution provider. Is that correct?
Photonic measurements. Yeah.
If we talk about disinfectant byproducts, we have normally no problems with that. There is a set legislation concerning chlorates, and we know how to monitor and control that. So for in the wash line, because that's our application, we think we have a good control of the disinfectant byproducts and also THMs, as shown within in the trial as well. But if another solution provider has ideas, I'm always open to receive that and see if that is possible to implement somewhere. Yeah, it's a good question, but I don't think we have at the moment some need for this. But if he or she thinks this is good for us and helps us in the whole process, I'm more than willing to have a look to it.
Thank you. So for the person who asked the question, if there is a follow-up on that one, maybe good to contact then Ewoud to have a talk about it.
Yes, thank you.
So I think I have asked and done all the questions. I think they have been all been tackled. So I hope. Is there any question that might arise now at the end of our meeting? No. So I think it has been a very nice webinar with quite some interactions. I invite you to keep on talking with each other. It's also very nice to see how innovators can talk with each other and learn from each other. So I think that's also very valuable from this. I would like to thank you all presenters for your nice and clear presentations. And I am looking forward to seeing you in our end event or in other opportunities. So thank you so much.
Thank you.
Thank you.
Everyone.
Thank you. Bye-bye.
Thanks all.
Bye.